All right, guys, that's not got this practice test. I'm going to apologize up front. All I've got is my Apple Pencil, which means you're going to hear a whole lot of clicks on the screen every time I write something. So sorry about that up front, but hopefully this helps a little bit. Okay, so first part says determine whether if the function is even, odd, or neither. Remember to test if it's even. I'm going to plug in a negative x everywhere there's an x. Can you hear that clicking? I'm so sorry. All right, so if I do a negative x in odd power, it stays negative. Even power, things are going to stay the same. It changes it back to positive. Plus 2, and because it's not exactly the same as I started with, or the exact opposite, means it's not even. To check odd, you plug a negative x and a negative y. So I've already plugged in a negative x, and it was this. So I put a negative sign in front of that f of x just to show that it was a negative y. So that's a neither, because neither, no matter what I did there, if I plugged in a negative x or negative x and negative y, I didn't get the same thing or the opposite. Part B, first hint on part B is both exponents are even. When your exponents are all even, that means it cannot be odd. So all I'm going to do is check for the even, which means I'm going to plug in a negative x. So I'm going to plug in a negative x up here, a negative x in my denominator. That's going to end up being the same thing, because when you square a negative, it goes back to what it was. It goes back to positive. So because I got the same thing, that means that one is even. And again, it's not even because the exponents are even, but it cannot be odd if the exponents are even. All right, number 2, determine it's even or odd. Even is if it's symmetric with the y-axis. Odd is if it's symmetric to the origin. And because A, if you turn it upside down, will look exactly the same. It's odd. B, look, is so close to being odd, because if I turn it upside down, if I do this, it looks almost exactly the same, except for the empty circles and the filled in circles, obviously. So because that's different, it's not even because it doesn't reflect across the y. It's a neither. It is absolutely a neither. All right, number 3. Rewrite the function if it's 3 units to the right and 2 units down. Remember those gestures we've done for like 2 weeks now? Seems like. 3 units to the right, opposite of what you think. So it's going to be minus 3, because you would think the right would be plus 3. Down 2 is outside, that's minus 2. Number 4, we're doing the same thing, just those gestures again. It says reflected across the x, which means the negative's outside. It says horizontal stretch by 2. Remember, that's the horizontal stretch and shrink are reciprocal. So because it says 2, I'm going to put the reciprocal in there in front of the x, and it says upward 3. That means the plus 3 is outside. And there you go. Number 5, I forgot to put which one was G. Good job on my part right there. And also forgot to ask the domain. Now, before you complain about domain, don't forget domain. You just do, for the first 4 here, it's like domain of that is all reals, domain of that's all reals. So when you combine them, your domain is also going to be all reals. So if I do F plus G, and by the way, I'm just adding straight across, just looking at those, I'm going to get 4. And my domain is all reals. If I subtract, I'm going to do x squared plus 1 minus this, minus the 3x squared. And I would get 2x squared minus 2. It's also all reals. C times G, I would do x squared plus 1 times 3 minus x squared. I would do FOIL here, which would give me negative x to the 4th plus 2x squared plus 3. And again, it's all reals. Part D, F over G. I'm just going to put function F over function G. Now this one, the domain is a little bit different because I have a fraction now. So I'm going to take my denominator and just set it equal to 0 just to see what it would take. So I'll move the x squared over here, take the square root, and you get plus or minus the square root of 3. Now, so my domain is going to be all x's except for positive and negative square root of 3. All right, when you get to part E, a little bit different. It's f of g of x, so I'm going to take function g and plug it into f. We look like 3 minus x squared plus 1. So if you square that, you square the first, multiply together, double, square the second, and don't forget the plus 1, which gives me x to the 4th minus 6x squared and plus 10. Now, the way you do domain on these, when they're composition like this one, like E and F are, is you do the domain of the second letter of that function, second function g, which is all reals, and look at your answer, your final answer right there, domain of it. Since they're both all reals, again, it's all reals. That was kind of lucky, but that's all reals. And part E, same thing. I'm plugging f into g this time, so I'm going to go 3 minus x squared plus 1 squared. Square, multiply together, double square. And then just do your subtraction. I get negative x to the 4th minus 2x squared and plus 2. That's your answer. Now, the domain, again, domain of f, which is the second one, and the domain of my final answer combined. Again, that's all reals. I don't know if you can fully expect to be all reals all day tomorrow, but I think several of them will be, so we'll see what happens. All right, number 6 up here. Okay, it says find g of f of g of x for those two functions. So work inside out. Take g right here, plug it into f, which would look like this, by the way. It would look like 2, it's the square root of 2 over x minus 4. But then you got to put that back into g. So I'm going to put that into where the x is on g, which is going to look like this. That's where the x is right there, minus 4. All right, and that's the first answer. That right there is what g of f of g of x is. And it says find its domain. Now remember what domain? Domain, you take the inside letter, the g, find that one. That right there, that domain would be x is not equal to 4. Now the tougher part is finding the domain of your final answer, which is right there. So since it's a fraction, it's got a fraction bar, the denominator must be positive. So I'm going to say, must not be equal to 0. So I'm going to take what's down there instead of equal to 0 and just solve it, which means I'm going to take the 4 over first, like that. I'm going to square both sides, which gives me 2 over x plus 4 equals 16. Cross multiply. Move the 64. That's a minus 4. I don't know what I'm doing. It's a minus 4. 66. Divide by 16, you get 66 over 16, which is 33 over 8. So my domain has two parts. It'd be x cannot equal the 4, because that was right here from the first part, and also the 33 over 8 that I just got. All right, so that's a pretty good problem right there, the domain part anyway. Okay, let me change colors here, go to number 7. Number 7, simplify, which means just add the fraction up. You need to find the LCD. Remember, the LCD is every single factor. The only two factors are x and x minus 2. But because one of the x minus 2's is x minus 2 squared, that's the one you have to use. So I'm going to go x minus 2 squared right there. Look at the first one and think about, what's this denominator need to be the LCD? Well, it needs the x minus 2 squared. All right, and x minus 2 squared, by the way, is x squared minus 4x plus 4. So I'm going to multiply the top, that 2 by that, and get 2x squared minus 8x plus 8. The second denominator needs an x and an x minus 2. It needs one more x minus 2, so I can get x minus 2 squared. So 1 times x is x. So if I multiply all that together, I get x squared minus 2x. I just say that. This one is just missing the x. So I'm going to do 3 times x. I'm putting 3x. And then add the stuff that you can. So I get 3x squared. That's a 3x. Minus 7x plus 8 all over x and x minus 2 squared. All right, that's it. Change colors again. Go to number, what are we on? Number 8. Number 8's got that radical equation. You know what I'm about to do here. I'm about to square both sides. But before I do that, I'm going to move the 1 over first, because you want to isolate the radical before you square both sides. Again, I'm sorry about this. I know this clicking is probably driving you crazy. It's driving me crazy. So square both sides. If I square the left-hand side, it's 5 minus x. Square the right-hand side, square. Multiply together, double. Square. Because I have a square, I need to factor, so I'm moving everything over here. If I move the x over, it becomes minus 5x. Move the 5 over, it's plus 4. Factor it, x minus 4, x minus 1. These are two answers are 4 and 1, maybe. Plug them both back in. If I plug the 1 in right there, it's already a no, because this 1 minus 2 would be negative 1. If I have a radical, that's a positive number, plus 1, that can't be negative 1, so that's out. If I plug in 4, yes, it works. So make sure you check your answers on 8. Number 9, determine whether y is a function of x. The way you know y is a function of x is the definition. Remember, every x has exactly one y. So to find that out, let's solve for y here. Let's move the 16 over here to equal y to the 4th. And then to get the y by itself, or to isolate it, I'm going to take the 4th root. And when you take any kind of even root in an equation, you need to put a plus or minus in the front. And that's a huge deal, because that means every time you put in one number in for x, because there's a plus and minus in front, you're going to get two numbers for y, which means every x had two y's. So it is not a function. Not a function. All right. Piecewise. Graph the piecewise. Remember, start out by plugging this negative 2 in there. If I plug in the negative 2, it gives me 4, so I'm going negative 2, 4, empty circle. because there's no equal sign there. And because it's saying go to the left or less than, I'm going to go left of -2, which puts me at -3. So I'm going to plug a -3 in there. -3 plus 6 is 3, so I'm going to go to -3, 3, which is right. I'm messing up. It's right there. Sorry about that. Let me do that again. I'm hard to see my graph. And because I know that's a line, you just need 2 points. You can connect those dots, and you got it. And then do this. Let's take the -2 here, plug it in. -2 squared is 4, and it's filled in. And because it's saying go to the right, I'm going to plug in a few more. I know it's going to be a parabola. If I plug in 1, which is to the right, I get 1. Plug in 0, I get 0. Plug in 1, I get 1. Plug in 2, you get 4. That first point is actually -1 I plugged in. Then you can see the parabola taking shape, and there's your picture. Number 11, state the domain of a piecewise. The domain, all that matters is the bottom must be not be 0. So I'm going to factor it. I'm actually doing slide, divide, slide in my head here, which gives me -3 there and +1 there. So here's what my domain is. The domain is all x such that x cannot equal -1/2 or +3. That's your domain. And last one, rationalize. I showed you 2 ways in class today. To make this video shorter, I'm just going to do it one way here. That's the cube root of x. To take the x out of a cube root, you would need 3 x's. Right now I only have 1, so I've got to multiply by 2 more x's so that I will have 3 x's in my denominator. So now my denominator is here, which is really just x. My numerator, I'm just going to do 3 times the cube root of x squared, and you have it. That's all you got to do. All right, so hope that helps some. Use as much as you need to. I'll put it up there sometime this evening. Not that it matters to you. But anyway, sorry for the clicking. Hope it helps. See you tomorrow.